Testing sound. Okay. Okay. Good evening, students. Am I audible? Am I audible? Am I audible? Yes, right. Okay. Okay. It seems students are still joining in, so I'll wait for another like 2 minutes and start. Right. And once you join, if you haven't downloaded the tute yet, I have pinned a message in the chat box, so you can go there. You can visit that link and download the tute. Right. You can visit the link that is pinned in the chat box. Right. So please go there and download the route and get ready. I'll be starting in another 2 minutes. Right. So get ready yourself for the session. I have uploaded the route there. Please download the route and prepare yourself. Please download the route and prepare yourself. Okay. Okay. Good evening again. Good evening again. We'll start the session now. Yes. So first, yeah, it seems still students are joining in, but anyway, I'll start now. It's 7:05, 7:05. So we'll start. Right. Mm, First thing is the importance of this session, because this is an exclusive session for graph plotting for A-level physics that I'm conducting. First, I'll explain the importance of the session here. Right. So first thing is, sometimes you might know, you might not know, because since this is an open session for all students, here 25, 26, or 27 students can be here. So therefore, I'll explain the importance and the gravity of this session first, right? So that is, when it comes to our physics MCQ paper, right? When it comes to paper one MCQ, we have 50 MCQs. And from these 50 MCQs, there are around 10 questions from graphs. Right? 10 questions means 10 marks, right? All 10 marks. And from paper two, in structured essays, we are getting 4 structured essays, and for each structured essay, right? For 95% of structured essays, actually, there's a supporting graph that we need to deal with, right? So therefore, usually you will get 4 graphs with 4 structured essay questions you are getting, right? So there also the total allocation for a structured essay question is 20 marks, and once it is divided to 50, there will be 5 marks for each. For graph, from structured essay and essay as a collective amount, if I say 5 marks from the second paper, right? Let's say 5, it will be around 4 to 5. It will be around 4 to 5, and here 10 marks. So as a collective mark, that is around 15%. So that is around 15%. So collectively, that is around 15% from our whole paper, right? 15% is a very life-changing mark. 15 means that's 15 marks. For a essay question also, you are getting 30 marks, right? For essay, 30 marks. And once it is divided by 4, for essay, it will be 7.5 marks. Now, this is 15 marks out of 100. 15%. 15%. This is 15 marks out of 100. So, therefore, the importance of graph plotting is very high, and the impact of graph plotting is very high, right? 15 marks means that is truly a life-changing mark, right? So that's why I'm conducting this session exclusively for graph plotting, right? So it doesn't matter in which level you are in graph plotting. I'll be starting from scratch, and I'll be explaining everything from zero. And it doesn't matter whether you don't know anything about graph plotting now, but by the end of the session, you will get to know the things that you need to know about graph plotting, and you will be doing the exercises I have given in the tute with me, right? Okay, then I'll start. Let's go to the lesson. Okay, first I'll explain the general things about a graph you should know. General things in the sense about a gradient, intercept, and those things, right? Sometimes from all levels also, you have heard these things and you have come across these things. But since I'm starting from zero, starting from sketch here, I'll explain the general things that you need to know about graph plotting first, right? So as a heading, you can put graph plotting. And graph plotting is a common thing for all 11 units. So this is skill is needed throughout all 11 units, right? So therefore, there is no particular place that or a certain lesson where you should know graph plotting. No, that is throughout. Right? Okay, graph plotting. And as the first heading, write down gradient of a graph. First heading, gradient of graph. First heading, gradient of graph. Gradient of graph. Okay. Look at the board. Let's say we have a graph of phi and x like this, right? And if I extend these two, this is the difference of x in this graph. This height is the difference of x, delta x, right? And this height is, delta y, and this length is, this is delta y, and this length is delta x. Difference of x, and this height is difference of y, right? Gradient of a graph is defined as gradient. See, gradient. We denote it by simple m, right? The standard notation is simple m. And gradient of a graph is denoted by delta y over delta x. Delta y over delta x. Gradient of a graph is denoted by delta y over delta x. And if I use this triangle, you can see, and if I label this angle as theta, always in maths and physics, the standard direction of measuring angles is anticlockwise. So that is why this arrow is also put. Right? Standard direction of measuring angles is anticlockwise. So if that anticlockwise angle with horizontal axis or x-axis is theta, this ratio is exactly equivalent to tan theta, no? Because tan theta is, we all know, tan theta is opposite side over adjacent side. Opposite side is delta y, adjacent side is delta x. So therefore, the same thing can be written as tan theta. Same thing can be written as tan theta. So therefore, we only have two ways of writing a gradient of any graph, only two ways. So gradient can be written as either delta y over delta x, either delta y over delta x, or as tan theta. Highlight this. Either delta y over delta x or as tan theta. Highlight this. Take it down. Take it down. Gradient of graph. Gradient of graph. Take it down quickly. If you have any questions or any clarifications needed, please forward your messages to chat box. Okay. You can forward all your questions to chat box if you have anything to clarify regarding the session. At any time, if you got any doubt, any clarification needed, forward your questions onto the chat. Right? Okay. Next thing is about the sign here. Next thing is about the sign here. Look at the board again. Now, if this angle is, if this angle with horizontal axis is an acute angle, if this angle with horizontal axis is an acute angle, right? If there is an acute angle, gradient is plus. If there is an acute angle, gradient is plus. The reason is this. Gradient is tan theta, no? Gradient is tan theta. Tan values from 0 to 90 are all positive values. And tan values from 90 to 180 are negative values. Right? So therefore, now if there is an acute angle, the tan value varies from 0 to 90. So therefore, gradient is plus. Right? And the next thing is, if this angle is an obtuse angle, if this angle is an obtuse angle like this, see, if this angle is an obtuse angle like this, obtuse angle, always you'll be measuring angles in counterclockwise or anticlockwise direction. That's a standard in maths and physics, right? So if this angle is an obtuse angle, obtuse, if there is an obtuse angle, the gradient is minus, and the gradient is m is minus, right? Because that happens with the values of tan theta. Tan values from 0 to 90 are all plus values, and tan values from 90 to 180 are all minus values. So therefore, the sign of gradient, this is the sign of gradient. Sign of gradient changes plus and minus like this. So simply, the takeout, the learning from this is, if the angle measured with horizontal direction is an acute angle, that's a plus gradient, a positive gradient, right? Positive gradient. If that angle is an obtuse angle, that's a negative gradient, right? So this is a positive gradient, positive gradient. Take them down, take them down. Positive gradient. And this is a negative gradient. And this is a negative gradient. This is a negative gradient. Take them down quickly. Take them down. Take them down quickly. Take them down. Okay. Okay. Now let's see what the gradient types are. Now with this thing, with this learning, now we will see some different gradient types. And here I'll discuss all gradient types we have. And you have to know about all gradient types. Right? And as the next heading, write down gradient types. Next heading, gradient types. Gradient types. Next heading, gradient types. Gradient types. In linear motion also we have discussed about this for 26 and 27 batch, right? So you know this already. You know about gradient and gradient types already. Now since we are starting from scratch, I'm recalling everything again, right? Gradient types. Gradient types. Look at the board again. Look at the board again. Y and X, right? See, I have drawn all gradient types we have on a single graph. See, I have drawn all gradient types we have on a single graph. Look at the board. So put your full attention to the session and be here in the session. Then after this session, after these 2 or 3 hours of time, definitely you will do all graphs that we have, right? And you will practice the questions I have given in the tube, right? Sometimes you might not know how to draw a graph now, but after the session, definitely you would know, right? Okay. Now our learning is we know gradient is tan theta, right? From the angle, gradient is tan theta. Gradient is tan theta. Since gradient is tan theta, now I'm going to check the angle of this first part. Now I have drawn different types of gradients. I'm going to check the first part here. See, look at here how this comes. Now if I check the first shape like this, now if I need to get an idea about the angle with the horizontal axis, see, I can draw a few horizontal lines and check it out. See, this is the angle here. This is the angle here. This is the angle at this point. This is the angle at this point. So you can clearly see that angle increases. That angle increases. But that is an acute angle. That is an acute angle. So therefore, since the angle is acute, gradient is plus. Since the angle is acute, gradient is plus. The angle increases. When the angle increases, tan theta increases. When tan theta increases, gradient increases. So therefore, this is called a positively increasing gradient. This is called a positively increasing gradient. So that is how we check on gradients. That is how we check on gradients, right? So therefore, this is positively increasing gradient. Positively increasing. Now, if we check the same for the second curve here, if we check the same for the second curve here, the curve is like this. Curve is like this, right? Now, if I check the angle, see, angle is same at any point. Angle is same at any point. This is an acute angle. Since the angle is acute, gradient is plus. Since the angle is acute, gradient is plus. Since the angle remains constant, gradient remains constant. So therefore, this is called a positive constant gradient. A positive constant gradient. So this one, positive constant gradient. So likewise, we can check the angle. We can check the angle for each and every section of these curves here, and we can check out the gradient types, right? Now, if I check the third shape, look at here. That is like this. The shape is like this. Now, if I check the angle, with horizontal, see, this angle decreases with the graph. Angle decreases. But still, there is an acute angle. Since there is acute, gradient is plus, angle decreases. When angle decreases, gradient decreases. So therefore, that's called a positively decreasing gradient. So this is positively decreasing gradient. Positively decreasing gradient. I'll explain the rest as well. Can you take this down? Because I'm going to erase this part. Take this down. Take it down. Let me mention here. Meanwhile, now if I take this fourth shape, it is like this. Right? The fourth curve is like this. Now, if I check the angle down the line, see, if I check the angle again, the angle here is this. That is this one. Now you can clearly see this angle is an obtuse angle. Since this angle is obtuse, this is negative. Since the angle is obtuse, that is negative. Now the angle decreases. Right? Along the line, angle decreases. But when the angle decreases, the magnitude of tan theta decreases. When that decreases, the value of the negative value increases. Right? The actual value of the negative value increases. So therefore, it is called a negatively increasing gradient. That is called a negatively increasing gradient. The reason is now actually tan theta decreases. But that decreasing value is a negative value. Right? Negative decrease means an increase. As an example, -4 is less than -3, less than -2, less than -1. So likewise, when the negativity of the value increases, right? Which means actually the value, negativity of the value decreases, the actual value increases. So that is what happens here. Tan theta decreases, but when tan theta decreases, the negative value decreases. So the whole value increases, the absolute value increases. So therefore, this is called a negatively increasing gradient. Negatively increasing. Right? So likewise, we can check it for all these curves. And here this is negative and constant. Negative constant gradient. And this is negatively decreasing. Gradient. Negatively decreasing gradient. And in this curve, this is horizontal. Once a curve is horizontal, tan theta becomes 0. When tan theta is 0, m equals tan theta. When theta becomes 0, tan theta is 0. When tan theta is 0, m is 0. So therefore, gradient of this part is 0. The reason is theta is 0 here. Theta equals 0. M equals tan 0. Therefore, m equals 0. Right? And this one, vertical line, the angle is 90. Theta becomes 90. Then gradient is tan 90. Tan 90 is infinity. Right? So therefore, this is called an infinite gradient. Right? So these are the all types of gradients you should know. All types. Take it down quickly. The learning takeout here is you should know these gradient types at a glance just by looking at the shape of the curve. You should be able to say of the gradient. Right? That's the learning outcome here. Take it down. It doesn't matter in which level are you, right? Please put your fullest attention to this session and spend the time here. And by the end of the session, definitely you will get to know how to plot graphs. Take it down quickly. Take it down. Now, I'm repeating again. If you got any questions, anything to verify, feel free to forward these questions, forward those questions to the chat box. Huh? Okay, right. Right. Is it all clear up to here? Quickly respond. Is it all clear up to here? Is it all clear up to this point? Students, is it all clear up to this point? Or if you got any questions, don't hesitate to ask questions. Right? You don't need to hesitate to ask questions. Right? Otherwise, you will stuck. You will get the same doubt, and you will stuck in the main exam at the main exam, A levels. Right? All clear up to here? Clear. Right? Good. Good. Right. So we are moving on. We are moving on. As the next heading, take down standard curves. Next heading, standard curves. Standard curves. Standard curves. Next heading. Standard curves. Standard curves. Right. So here what we are going to discuss is we have different types of standard curves. Defined standard curves. So we have to have a clear idea on the shapes of the standard curves. Right. So therefore, first I'll split the standard curves into two categories as linear curves and non-linear curves. Right. So under this, as the first subheading, write down non-linear variations or non-linear curves. Non-linear. Sorry. First, let's go with linear. Right. Let's go with linear first. Under this first one, linear variations. Linear variations. Linear variations. So I can denote a linear variation like this: y equals m x to the power n, right? When n equals 1, such variation is called a linear variation, right? So I hope it's clear. The equation is in the form of y equals mx to the power n, n equals 1. Such variation is called a linear variation, right? Okay. So first let's see what the linear standard curves are, right? We are in standard curves. So I'm splitting this to two. I told you linear variations and non-linear variations. And in linear variations, now we are going to see the standard curves, right? Look at here. Look at here. Y and x. Y and x. Right. Now, first type of the linear variation. Right? First type, y equals mx. Y equals mx. Gradient is positive, and the power of x is 1. Right? Linear. Gradient is positive. Positive gradients means acute angles. Huh? Now, if I plot y equals minus mx on the same, see, this is how it goes. Y equals minus mx. Right? It goes through the origin. Y equals minus mx, because when the gradient becomes minus, you know now The angle with horizontal is obtuse. See, now the angle is obtuse, right? And we call uh, the intersection of y, intersection of y axis is called intercept, intercept, and it is denoted by c, right? Intersection of y-axis is called intercept, and it is denoted by c. Now, if I add c for these linear variations, this is how it goes. Now, when this curve intercepts at this point, this is called y equals mx plus c. Y equals mx, m determines the gradient is the angle, and c determines the point where it intersects the y-axis, right? C determines the point where it intersects y-axis, right? So you can see it from the variation. Now, when y-axis is intersected, x value becomes 0, value of x becomes 0. Now, if you make x 0 here, see, in the variation, if x is 0, y equals c. So that's the meaning. That is why we call c is the intercept. Intercept is where the y-axis is intersected by the graph, right? And this one, if this is minus c, this is y equals mx minus c. Y equals mx minus c, right? These are the standard curves, huh? Standard curves. And this is y equals minus mx plus c, minus mx plus c. And this this is y equals minus mx minus c. So these are all, listen, listen, these are all standard linear curves you should know, right? These are all the standard linear curves you should know. And I know from models also you know a few of these graphs, right? So we are recalling again from the beginning. Take it down, take it down. If you are using different colors, you can use different colors and take it down quickly. And please make sure that your diagram is clear enough, because you should be able to refer this at any point in your A-level journey, because I told you the graph knowledge is going to be used throughout all 11 units in A-level physics, right? So therefore, even though you are learning graph plotting here, it doesn't mean that it is required to a certain lesson of the syllabus. No, it is needed throughout, right? So therefore, take them down very clearly. Take down. This goes through the origin point. This goes through the origin point. Write it down quickly. And if anyone doesn't know what intercept is, this is the intercept. Huh? Intersection of y-axis. Intersection of y-axis is called intersection of y-axis is called intercept, and that is denoted by c. That is denoted by c. Okay, take down quickly. Write down quickly. And please forward your questions if you have anything. double check these ones that you have written. These are the standard shapes. Y equals mx, y equals mx plus c, y equals mx minus c, y equals minus mx plus c, minus mx minus c. Write down quickly and clearly. Write it down quickly and clearly. Okay, right? Okay. Another small announcement that I want you to give is that I'll be starting the paper class for 2025 batch next week onwards, right? And that will be conducted fully online as a fully online class, and you'll be writing a full syllabus, full paper with me, right? And we'll be discussing it. The discussion also goes, and that will be fully online, and we'll be providing the marking scheme as well. And even though the target batch is 2025 batch, right? Any one of you can join and see in which level are you when writing questions. Uh, if you are in my Telegram channel and other groups, you might have already seen that I have circulated the flyer that I'm starting the paper class next week, right? So just pass the message if there's anyone who is willing to join, or if there are any friends, colleagues of you that who are seeking a paper class, you can share the message, right? Right. Next one, number 2 here, nonlinear variations. Number 2, nonlinear variations. Number 2, nonlinear variations. Write down nonlinear variations. Number 2, nonlinear variations. In nonlinear variations, we have few types, right? So therefore, we will discuss one by one. Under that, type 1, under that, row number 1, right? Write down, row number 1, write down y equals m x to the power n when n is greater than 1. This is the type 1, right? Y equals mx to the power n when n is greater than 1, right? As an examples, they are like y equals mx squared, y equals mx cube, mx to the power 4, such curves, right? So let's see. Sorry about that. Let's see. First, I'll explain using y equals mx squared curves, right? And from nonlinear variations, listen, from nonlinear variations for A-level physics, for 95% of questions, we will need the variation only in the first quadrant. First quadrant means that is between the positive values of x and y, right? But to you to see the proper shape of the graph, First, I'll draw the entire shape, and then I will summarize to the first quadrant. First quadrant means for positive values, right? Look at here. Look at here. Now, as the example curve, I'm going to choose y equals mx squared, right? It satisfies this, no? Y equals mx to the power n greater than 1. So, as the example curve, I'm going to take y equals mx squared, right? That's a curve that you have already dealt in O levels as well. Mx squared curve, quadratic curves, right? Now, if I plot y equals mx squared, that will be something like this. This is the shape. Y equals mx squared. This is the shape of y equals mx squared. Now, if I plot y equals minus mx squared, if I plot y equals minus mx squared, it goes like this. Y equals minus mx squared. It goes like this, right? And now if I add the intercept to these curves, see what happens. If I add intercept, it is like this. This curve is y equals mx squared plus c, because the intercept here is plus c, right? So that curve is y equals mx squared plus c. And if the minus the intercept is, let's say, minus c, then this curve is y equals mx squared minus c. Y equals mx squared minus c, right? And if I plot this kind of a curve like this, this is y equals minus mx squared, but the intercept is plus c. And if I plot this variation like this, this is y equals minus mx squared minus c, minus mx squared minus c. So these are the standard nonlinear type 1 curves you should know, right? But I'm repeating again, for 95% of A-level physics questions, we will only need to know, right? We will only need to know the variation in first quadrant. First quadrant means here, between positive values of x and y. So therefore, after this, I'll summarize this. The reason to draw the entire graph is to you to see the full shape of the graph, the entire shape of the graph, right? Take it down. Take it down. Take it down. Use different colors. Use different colors if you have, because then you can easily see the comparative graphs, right? Take it down. Take it down quickly. And forward your questions if you have anything, right? Repeating again. Forward your questions if you have anything. Okay, right? Now, if I summarize the main curves we have, and if I compare it with the index here, right? It will be like this. Look at this. Now, if I summarize the main types of curves we have in the first quadrant with their index, right? I'm going to compare them with the index. See? Now, if let's say y equals mx squared is like this, y equals mx squared is like this. Now, if I plot y equals mx cube on the same plot, if I plot y equals mx cube on the same plot, it is like this, mx cube, right? the increase of the curve is rapid compared to mx square because that is the increase of a power of 3, right? A cube. So therefore, it is rapid increase. And if I plot a curve like y equals mx to the power 4, right? It will be another rapid increase compared to both. So therefore, if we plot these main curves on the first quadrant like this, and if we compare it with the index, this is the impact of the index. Higher the index here, always the graph comes towards the y-axis because the increment is high. Increment is high. Higher the power, higher the index, higher increment. Right? Take it down. Take it down quickly. Take it down. For 2026 batch, we will be starting Archimedes theorem this week, this Thursday. And for 2027 batch, we'll be starting linear motion graphs this week on Wednesday. Linear motion graphs. Linear motion graphs is a small lesson, so we'll finish the full lesson on the same day. Okay, finished? Finish taking down, right? Okay, we are moving on. Moving on. Next one, Rome number 2. Rome number 2. Only very few theories are here, right? So put your fullest attention to these theories, and then you will easily grab the science behind or the concept behind plotting graphs. Very simple thing, very simple thing. Easily you can secure your 15 marks, right? And second type, take down Rome number 2. Rome number 2, y equals mx to the power n, right? Y equals mx to the power n when n is greater than 0 and less than 1. Take this down. Y equals mx to the power n when n is between 0 and 1. Between 0 and 1 means for decimal indices like root is the index of half. Cubical root is the index of 1 over 3. So they are falling in this range, right? So therefore, as the example curve, I'll be taking this. I'll be taking y equals m root x. So as the example curve, I'll be taking this. And if I plot y equals m root x, this is how it is going to be. This shape is y equals m root x. And simply, the idea is like this. So look at here. If we have y equals mx squared curve, right? Mx squared curve, to this term x, it has two roots. No? So basically, it has two roots. X has two roots because that's a square, right? A square. Now, y equals mx root means, right? Mx root means, m root x means, now if you square this is like y equals mx, y squared equals mx, right? The square of m is also m because that's a gradient, no? The square of gradient is also a gradient. So therefore, if you square this is like y squared equals mx. Now for y here, that is going to have two roots, right? A simple idea, no? In any quadratic equation, of power 2, right? The term with that index with the power 2 has two roots. Now in these equations, as we have two answers for x, in these equations we have two answers for y, right? That's the difference. That's the comparison. So this is y equals m root x. Y equals m root x. And this is going to be, this is going to be what? This is going to be y equals minus m root x. Y equals minus m root x. And if I add the intercept, see, if I add the intercept, it is like this. So if this is C, this curve is like y equals m root x plus C. And if this is minus C, this curve is like y equals m root x minus C. Right? And doing the same, this one is y equals minus m root x plus C. And this curve is y equals minus m root x minus C. Right? Right? So these are the basic standard curves you should know from this range. Right? Like y equals m root x. Y equals m root x. Right now, can you explain it again, sir? Yeah. Now, as the example equation, I chose y equals m root x because now x falls in between this range. No, if n is between 0 and 1, root is the power of half, right? So you know, right? Y equals m root x means this is m x to the power half. Root is the power of half. So as a example curve, I took y equals m root x, right? And if I plot y equals m root x, this is the standard shape of the y equals m root x. Y equals m root x. And what I was explaining before was now as we have two answers for x squared equations, this is a y squared equation. So therefore, here for y squared, it will be two answers. For a given x value, see, now for a given x value, there are two y values. For a given x value, now if you extend this line, you can see, if you extend this line here, like this, for this given x value, let's say x equals 1, from here also we have y value, from here also we have y value. So that is what I explained. For a given x, there will be two y values. And if we add the intercept, it will be like y equals m root x plus c. Here, it intercepts with the plus c plus intercept here. And y equals m root x minus c here. And similarly, these are minus m root x curves with plus c and minus c. Right? Take it down. Take it down. So likewise, please raise if you have any questions. And if you didn't get what I said, that's also fine. You can always ask questions and you can ask for clarifications. And I'm always happy to hear your questions. Take it down quickly. And then again, I'll summarize the important ones here. Right? Again, I'll summarize the important ones here as I did in the previous one. So first, take this down. Then I'll summarize. right? And now if I summarize and compare, again, I'm going to compare as I did before, right? If I compare these curves here, x, y, see, let's say this is y equals m root x, y equals m root x, right? The shape of the first quadrant, y equals m root x, right? This shape, is the shape of the first quadrant, y equals m root x. And if I plot a graph like y equals mx to the power 1 over 3, it is further below that curve because the decrease is rapid. And if I plot a graph like this, a very high power like this, y equals mx, let's say to the power 1/4, it is further below. Right? Compare these things. Now in the first one, I brought y equals mx squared, mx cubed, and mx to the power 4. And here I have m root x and mx to the power 1 over 3 and mx to the power 1 over 4. Right? So this is how it plots. Take it down. Right? Take it down. And if you didn't get anything that I say, code your questions. Right? Okay, we are moving on. And row number 3 here. Right? We are moving on. Part 3, row number 3, y equals mx x to the power n when n is less than 1. When n is less than 0. When n is less than 0. When n is less than 0. Right? Y equals mx to the power n when n is less than 0. N less than 0 means the value of n is negative. Negative. So we call them inverse curves. Inverse variations. We call them inverse variations. Take it down. Inverse variations. Right? Now, as the example curve, I'll be taking y equals m 1 over x. Right? 1 over x means x to the power minus 1. Right? This is clear, right? Look at here. Y equals m 1 over x. So this is actually y equals mx to the power minus 1. So therefore, as the example curve, I'm going to consider this y equals m1 over x. Right? So right here. X and y. If we plot y equals m1 over x, m times 1 over x, this is the curve you are getting. Now, if I quickly explain what's happening here, look at the board. Y equals m1 over x. No, when x becomes 0, see, when x becomes 0, y goes to infinity. When x becomes 0, 1 over anything, 1 over 0 is infinity. Anything over 0 is infinity. 1 over 0 is infinity. So therefore, y goes to infinity. And when y equals 0 also, when y equals 0, x is 1 over infinity, 1 over 0 again. So there, x goes to infinity. So therefore, these curves are infinite curves. And this is how we are getting these curves. If I plot a curve like y equals m1 over x. This is what we are getting. To show that it's reaching infinity, we are plotting this last part of the graph parallel to the axis to say that it's reaching infinity. Now, otherwise, we can't plot infinity. No, we can't plot infinity because the infinity is not defined in reality. It is not defined. So that is not a defined point. So therefore, to show that it goes up to infinity, right? We are making it parallel with the axis. Here also same. I'm making this parallel with the axis to show that it goes to infinity from this side and it goes to infinity from that side as well, right? And the rest of this same curve is here. These are not two curves, right? Don't mess up these two. These are not two different curves. This is a single curve, same curve on the same axis, right? So when it goes to plus infinity from here, the curve again comes to the axis panel from minus infinity like this, right? So therefore, this is also the same curve. This is how it behaves for negative values of x. So you can apply a negative value and see. This is same curve, same curve. This is the same curve, right? We can't see the consistency of the curve because it goes to infinity and minus infinity. That's why we don't see the consistency. Otherwise, the curve is consistent, but we don't see it, right? And if I plot this kind of a variation, this is y equals minus m over m into 1 over x. And the rest of the same curve is here. So use same colors, then you can see this properly. So this is how it goes. Right now, as this example curve, I used y equals m1 over x, right? And this is how it behaves. And then again, I will summarize. So before the summary, take it down. Take it down before the summary. Quickly, copy it down. Right? Okay, now if I summarize the first quadrant, it's like this. All inverse curves has the same shape. All inverse curves has, see, y and x. All the inverse curves have same shape. Inverse in the sense, if y and x are in denominator and numerator, right? If y and x are in denominator and numerator, that's an inverse curve. Inverse. Because when x increases, y decreases. And when y increases, x increases. So if you have y and x up and down in both sides, in numerator and denominator, that's an inverse curve. That's an inverse curve. Now if I plot, see, y equals, let's say 1 over x. If I plot something like 1 over x, m1 over x, it is like this. And if I plot this one, what is this? This one is m1 over x squared, that is further inside. Further inside, the reason is a rapid decrease is here. A rapid decrease again. Compared to the power of x, this decreases with x squared, a rapid increase. Right? Rapid increase of x, so that's a rapid decrease of y. Rapid decrease of y. Y rapidly decreases. And if I plot a further higher curve like this will be something like y equals m x to the power cube. So likewise, higher the power of an inverse, right, it comes towards this side, comes towards the origin, and these are the easiest types of curves to know, inverse curves, because all inverse curves has this same shape. This is called the inverse shape. Because of that reason, this shape is also called the inverse shape. That's the easiest type of curves we should know. Right? Take it down. Take it down. Take it down quickly. Take it down quickly. And ask your questions if you need any clarifications. Ask your questions if you need any kind of a clarification. Right? If you need any kind of a clarification, right? Follow all your questions. Take it down. Okay. Actually, from here, all the theories you should know about the graph plotting is done. Right? Theories. As theories, these are the parts you should know. And I'll summarize everything again. Like this. Take this as a summary. See? Take this down as a summary. Summary. So this is what happens if I plot all these curves on the single axis panel. See? This is y equals mx. This is y equals mx. And this is y equals mx squared. And this is y equals m root x. And this is y equals m 1 over x. Right? So if I plot these main curves, on the same axis panel like this, right? This is how it looks. Take it down as a summary. Take this down as a summary. Summary. If you plot all y equals mx squared, m root x, and m1 over x on the same graph, this is how it looks. This is how it looks. Take it down quickly. Okay. 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 Now, from here, all the theory parts you should know about this graph plotting is done, right? So very simple, very simple. Now we are going to start some exercises, right? So I'll give you 2 minutes first. 2 minutes. Quickly go through what you have taken down from the beginning. Quickly go through what you have taken down from the beginning. Then I'll explain how we are going to plot a graph using these standard curves. Right? Quickly go through everything you have taken down from the beginning, and meanwhile get ready with the root. Get ready with the root. Be ready with the root. Right? I have pinned a message in the chat box if you haven't downloaded the tute yet. So you can visit that link and download the tute. Right. So quickly go through what we have covered so far. Quickly go through what we have covered so far. And if you have any kind of questions, any doubts, anything to clarify from my side, forward your questions. Right? Questions are always welcome. Questions are always welcome. For 25 students, now you have only got 19 weeks from this point onwards, right? Just 19 weeks. And there might be 25 students here in the live, right? So therefore, just 19 weeks. Increase these skills and polish up these skills, because around 15% of marks, is allocated for graphs. So that's a very gravity part, a part with a higher gravity. But sometimes students don't care that much about graphs. But that's a part with a higher gravity, 15 marks out of 100. Okay. Go to first question in the route. Go to first question in the route. It says a bus passes point A at an instant velocity u and instant acceleration a. Plot following variations. All terms have usual meanings. Right? Listen. A bus passes point A at an instant velocity u. Wait here. If this is the bus, this bus passes point A at instant velocity u. So velocity at this point, instant velocity is u, and instant acceleration a. So acceleration of the motion is a. Right? Now you are asked to plot Vt and St variations. Right? You are asked to plot Vt and St variations. Okay, clear? You are asked to plot Vt and St variations. Right? Now, this is the first exercise you are going to do with me. Right? This is the very first exercise you are going to do with me. First, listen to the explanation, and then grab this concept, and then easily you can complete all other questions before me. Right? If you got this properly. Right? Now, first thing is to plot a variation between V and T. Listen. To plot a variation between V and T, we have to have a relationship between V and T. Right? In order to plot a variation between V and T, first hand, we have to have a relationship between V and T. So therefore, using this given data, now I'm going to model this into an equation. We all know linear motion graphs, no? So therefore, considering this motion of the bus, I'm going to apply a suitable linear motion equation. Right? Considering this motion of the bus, I'm going to apply a suitable linear motion equation. U and A are given. And for the first graph, I'm interested on velocity and time. Right? So, collating all those things, I'm going to apply V equals U plus AT for this motion. See, look at here. Applying using V equals U plus AT along this direction. Look at here. V is V. Let's say final velocity. Initial velocity is given U. A is also given as A. And time is also given as T. Now look at here. Now, once we got this kind of a relationship among these terms, once we got the relationship among the terms, we have to take it to a standard form. We have to take it to a standard format of a curve, right? So this is how it's done. Now my y-axis is, look at here, my y-axis is y-axis. See, instead of y-axis, I have velocity. Instead of x-axis, I have time. So therefore, I'm going to subject y, and then we can identify x and y. Y is already subjected here. To see x properly, I'm going to write this as a times t plus u. No difference, no. V equals AD plus U. Now we need to identify x and y. In maths, we call x and y as independent variable and dependent variable. X is the independent variable. Y is the dependent variable. Right? So we need to identify the x and y terms, x and y variables from this shape, from this relationship. Right? Now for y, we have v. So therefore, this is y. V is y. In the given graph, v is acting as y. And t is acting as x. T is acting as x. And whatever the term which is multiplied with x, which is as a product with x, is the gradient. This is the gradient. And this one has to be the intercept. So therefore, that is y equals mx plus c. So this is the exercise, this is the task you have to perform to take any equation to a standard equation, right? Now this is a standard shape, y equals mx plus c. So everybody knows how to plot y equals mx plus c. So therefore, as the variation, what we are plotting is this y equals mx plus c. So therefore, this variation is going to be y equals mx plus c. This is the shape of y equals mx plus c, and c is u now. C is u here, and the gradient of this graph is acceleration. Gradient of this graph is acceleration. So the curve you should plot between v and t is this. So likewise, first we have to have the relationship. Once the relationship is known, from that relationship you have to identify xy terms, xy variables, and take it to a standard curve. You have to take it to a standard curve, right? And then once you have a standard curve in front of you, easily you can plot that as standard shape. So simple as that. That is how the graph is plotted. Let me explain the second one as well. If I need the variation between s and t, I'm going to use an equation like s equals ud plus half ad squared. See, using s equals ud plus half ad squared, right? I can write this as s equals, if I take this here closer, half a t squared plus u t plus u t. Right? Now identify these variables. S is y. T is x. So therefore, this is x squared. And this has to be the gradient plus this part is going to be the intercept. Now, what I have got is y equals mx squared plus c. So the shape of mx squared plus c is like this. So this is y equals mx squared plus c. The shape is y equals mx squared plus c. Right? The shape is this. So this is the activity. This is the small activity you have to perform to take any graph to a standard shape. So once you have a standard shape with you, you can easily plot that standard shape as a graph, right? So since these two are the very first two questions I explained from scratch, And hereafter, I have given few exercises in the dude. So we will be discussing all given exercises one by one. We'll be discussing all given exercises one by one. So take this down, take this down, take this down, and raise your questions if you have any. Raise your questions if you have any. Raise your questions if you have any. Quickly take it down. So understand what we did. So once you understood this concept, this is nothing. Once you understood the concept, this is nothing. Quickly take down. Okay, finished. Forward your questions if you have anything. Forward your questions if you have anything. Right? Shall we move on to the second question? Question 2. Okay. Go to question 2. Go to question 2. Question 2. Rotational kinetic energy E is given by E equals half pi omega squared. Right? So this is a very known equation, popular equation in rotational motion. E equals half pi omega squared. Right? Plot following variations of E with omega. Plot following variations of E with omega. Right. So let's see one by one. Now the equation is also given. Now with the second one, equation is also given. Since the equation is given, you just need to take that equation to the standard form that you need to plot that particular graph. Right? Okay, let's see one by one. Now, if you can try before me, you can try out and check the answers with me. Right? If you can try it out before me, you can try out definitely and check the answers with me. Right? Okay. E equals half I omega squared, and the first curve is E with omega squared. Look at here. First curve is E with omega squared. E with omega squared. Right? Now, the known equation is E equals half I omega squared. Equals half I omega squared. My y-axis is already subjected. Right? This is my y-axis, this is my x-axis. Already subjected. So therefore, I'm going to identify the terms here itself. E is acting as y. And omega squared is x. This whole term omega squared is x. Now, if you need to make this a habit, right? If needed, until you are making this a habit, if needed, put x and y along with the given terms like this. Then you won't miss what x and y is. Now the x is omega squared. X is omega squared. So therefore, this whole term omega squared is x. So whatever it is as a product with x is the gradient. Whatever it is as a product with it is the gradient. So now the shape is y equals mx. Shape is y equals mx. So therefore, very straightforward, very easy. You have to plot the y equals mx graph here. Y equals mx. A straight line goes to origin. Y equals mx. Right? Second one. What's the second one? E with omega. Second one, E with omega. E with omega. Now again, the equation is same. Now E is still as y and omega is as x. Omega is as x. Right? So the equation is equals half I omega squared. E is still y. So E is still y. And now omega is x. Omega is x. Just omega is x now. Just omega is x now. So what omega squared is then? That is x squared. Right? Omega is x now. Just omega is x. So omega squared is x squared. And whatever it is as a product with omega squared, x squared is the gradient. So the shape is y equals mx squared. Shape is y equals mx squared. So this is a y equals mx squared. That's a y equals mx squared. Yeah. Right? So if you understood this concept behind graph plotting, this is a very simple thing. Very simple thing. And this is a must-know thing. This is a must-know thing and a simple thing. Right? So please grab this theory, grab this concept behind graph plotting. Right? Then hereafter, you can plot any kind of a graph that is given to you using the same method. Right? This is the same technique we are using to plot any kind of a graph. Same technique. Right? Make corrections if you have anything. What's the third one? E with 1 over omega squared. See? Third one. E with 1 over omega squared. I'll plot here. E with 1 over omega squared. E with 1 over omega squared. Look at here. This is a special curve. Special in the sense, here you have to do some kind of a modification. Now this is x. We are going to do some kind of a modification because the reason is this. Now the shape is equals, equation is half I omega squared. Right? Equals half I omega squared. But 1 over omega squared is given as x. 1 over omega squared is not here in the relationship I have. Right? 1 over omega squared is given. Even though 1 over omega squared is given, I don't have 1 over omega squared already in this equation. So therefore, we have to create 1 over omega squared in the equation without harming the equation. Right? Listen again. You have to create 1 over omega squared in the equation without harming to the equation. So that is called changing the shape of the equation. See, you know this, no? See, x can be written as 1 over x, no? No difference. X can be written as 1 over x. Same thing. Because division is reciprocal, multiplication with the reciprocal, no? So 1 over x is again 1 times x over 1. Answer is x. So therefore, 1 over x is x again. Now, as an example, as a numerical example, I can write 3 as 1 over 3. See? 1 over 3 is 3. Can you see? So I'm going to use that same idea here. Same idea here. So I can rewrite this equation as half I omega squared. I can write it as 1 over omega squared. I can write it as 1 over omega squared. No harm to the equation. No? Now, if I simplify this second line, the initial equation comes again. The original equation comes again. Right? No harm to the equation. So, without harming the equation, right? Without harming the equation, what we have to do is we have to reshape the equation. Right? Now my required term is included. My required term is included. Now I can identify the variables. E is y. E is y. And 1 over omega squared is x. 1 over omega squared x. Omega squared is x. So this is not x, this is 1 over x. This is 1 over x. And this part, which is as a product with this, is gradient. See, another standard shape, y equals m1 over x. That's an inverse curve. That's an inverse curve. So the shape is inverse. Shape is inverse. Right? So that is an inverse curve. Is it clear? Right? So if you have any questions, please forward. Please forward. Take it down quickly. Take it down quickly. I'll be raising the first one and the second one. Take this down quickly. So that is an inverse curve. So if the curve is inverse, what is inverse variation? Right? Next one, E with root omega. Look at here. Next one, E with root omega. E with root omega. The equation I know is again the same. E equals half I omega squared. E equals half I omega squared. No root omega is included in the equation now. No root omega is included. So therefore, we have to create root omega in the equation without harming the equation. Right? We have to create root omega in the equation without harming the equation. So now I'm going to create it without doing any harm to the equation. Look at here. I can write the same thing as half I using root omega. I can write the same thing as this. No, is it clear? Is it clear? Because root is the power of half. Root is the power of half. Then to the power of 4 is, we know the index simplifications. These two multiplies, half times 4 is x squared. So this is x squared. So I use this learning, this concept here. This concept here. So with this concept, I can write omega squared dash root omega to the power 4. Omega squared dash root omega to the power 4. Okay. Now my requirement is satisfied. I needed root omega in the equation. Now I have got root omega in the equation. Now I can identify these terms. E is y. Root omega is x. So therefore this is x to the power 4. And this part is the gradient m. Mx to the power 4. Mx to the power 4 is this kind of a variation. Mx to the power 4 is this type of variation. Right? Write it down. Check your answers. Now, if you have done the questions before me, you can check answers with mine. And if you have finished question 2, go to question 3. If you have already finished question 2, go to question 3. Right? If you have already finished question 2, go to question 3. Right? Let's go to question 3. So now you have understood this concept behind graph plotting, right? No need to wait until I discuss the question. Go to question 3 and finish the questions there. And then with the discussion, you can check whether they are correct or wrong, right? So that is how it should be. That is how it should be. Let's go to question 3. Okay, I hope it's clear. Any questions before moving on, students? Students, any questions up to here before moving on? Or if it is clear, say me it's clear, then I know that you are on track, right? Please, students, if you have any questions, please ask. I mean, from the things that we discussed up to this point, if you have any questions, please ask. And if it is clear enough up to this point, say it's clear enough. Quickly. Clear. Others? What about others? Clear. Clear. Okay, good. Let's go to question 3. Question 3. Read the question. Once you get this concept behind graph plotting, you can plot any graph, right? The shape changes with the axis, right? Always when the axis changes, the shape of the graph changes. But even if you are given any kind of axis, if you have the correct relationship, and if you can get it to a standard shape, you can always plot the graph. And other than the standard shapes, listen to this as well. Listen. Other than the standard shapes, if we are getting any not standard curves, right? Other than standard shapes, if you are getting any not standard curves, what you can do is always we can make x0 and determine the y-intercept. And we can make y0 and determine x-intercept. That is also a possible thing, right? Let me explain an example before moving on to the next one. Let's say you have an equation like, see, y equals 2 over x plus 5. You have something like this. Y equals 2 over x plus 5. Right? This is something additional. You get here. Now, if you got this kind of a non-standard one, what you can do is, now, first check the basic, first check whether it aligns with any basic standard curve. Right? Now, I can see x and y are inverse, no? So therefore, definitely this is going to be an inverse curve, but that is not an standard inverse curve. That is not an standard inverse curve. So therefore, in such cases, what you can do is, I know for sure this is inverse because y and x are in numerator and denominator, inverse. In such cases, what we can do is, we can make x0 and z to where y goes. See, when x becomes 0, here y equals 2 over 5, no? Y equals 2 over 5. So therefore, when x becomes 0, the graph starts at 2 over 5. When x becomes 0, the graph starts at 2 over 5. And then make y 0. When y equals 0, 0 into anything is 0. So x is going to be infinity. When y becomes 0, x is going to be infinity. Right? The reason is this. Now, if you need to see the simplification, see, 0 equals 2 over x plus 5. Right? So, if I cross multiply, x plus 5 equals 2 over 0. 2 over 0 is infinity. Infinity minus anything is infinity. So, therefore, x goes to infinity. X goes to infinity. So, the shape is the inverse shape, and it goes to infinity only from this horizontal axis. It goes to infinity only with the horizontal axis. And here that is having a finite value, a defined finite definite value, right? So keep this in mind. Keep this in mind, and you can take this down as a note. Keep this in mind. If you are getting any type of a non-standard shape other than to the shapes what we discussed, right? What you can do is always you can make x0 and y0 and get an idea about the intercept points. Always you can get an idea about the intercept points. And if you see a basic shape in the equation, definitely it will follow that basic shape with some kind of modifications like this. Now, since y and x are still inverse, that is an inverse curve. This is also an inverse curve, but this is not an standard inverse curve, right? Take down a note if needed. We are moving on to question 3. Take down a note if needed. Okay. Right. Next one. Question 3. Question 3. Go to question 3. Question 3. It says periodic time t of a simple pendulum is given by t equals 2 pi root L over G. Plot following variations of t against L. Okay, first one. Go to the first one. See, first one. T with root L. T with root L. Let me copy down all first. The second one, T with L. And the third one, T with L squared. T with L squared. And the fourth is T with 1 over root L. Okay. Let's see the first four first. T with 1 over root L. Right. First one. T with root L. Right. T with root L. The equation I know is T equals, look at the board, T equals 2 phi root L over G. Right. Now if I split these terms and if I isolate x, now this is going to be my x variable. This is going to be my x variable. This is going to be my y variable. Now if I isolate x from this can be written as 2 phi over root G into root L. No problem. 2 phi over root G into root L. Because from maths you know, root x over y can be written as root x over root y. All over maths. Root x over y can be written as root x over root y. So if I use the same here, right, I can write this like this. Right? Now, root L is here. I'm going to identify these terms. T is y. Root L is x. And whatever it is as the product with x is the gradient. So the shape is very simple. Y equals mx. So first one is y equals mx. Very simple. Once you understood this concept, you will plot any graph that is given to you. Definitely you will plot any graph that is given to you once you got this concept. Or very small concept. Right? So grab this thing and repeating again. If you have any doubts and if you need any clarifications, please forward your questions. I'm always happy to answer. Right? Take it down. I'm going to move on to the second one. Right? Second one. Second one is T with L. Okay. Still, my equation is same. See, T equals 25 root L over G. T equals 25 root L over G. 25 root L over G. Now again, I can write the same equation as the previous one. 25 root G times root L. Right? Now, I'm being asked to plot with L now. L is already here. So we can identify terms now. Identify labels now. T is Y. And L is X. See? Now for this graph, L is X and T is Y. Right? So therefore, L is X. So therefore, this is not X. This is root X. Because L is X now. And this part, which is as the product, is radian. So the shape is Y equals M root X. Again, a standard shape. Y equals M root X. Standard shape. So this is the shape of Y equals M root X. This is the shape of Y equals M root X. See how easy this is, right? So once you grab this concept properly, this is very easy. So that's why I told you can easily secure your 15 marks, right, from graphs if you know these things very properly. I mean, you have to have a solid understanding, a thorough knowledge on this. Very small concept. I mean, not a big deal. Not a big deal. Once you know this, easily you can plot any graph, right? Try them. Try them. Once you get this momentum, definitely you would go through. Once you get this momentum, definitely you would go through. Right? Third one. What about third one? What about third one? L squared, right? With L squared. Okay. The equation is same again. T equals 25 root L over G. So it can be written as 25 root L over root G. Right? Now, I need L squared to be created. I need L squared. I need L squared to be created. Right? I can write the same without harming the equation like this. No? See? E equals 25 over root G. And here, what if I write this as L squared to the power 1 over 4? What if I write the same equation as L squared to the power 1 over 4? Now, if you simplify this line, again the same line comes. Index simplifications. Because we can write this as, see, we can write root x as is equal to x squared to the power of 1 over 4. Using this concept, using this, we can write root L, like this. Right? We can write root L like this. Now, the term I needed to create here is created. Now, identify terminals, identify variables. This is y, and L squared is x. L squared is x. So, this is x to the power 1 over 4. Only L squared is x. Huh? Only L squared is x. This is x to the power 1 over 4. And whatever this is as a product with x is the gradient. Right? So, m x to the power 1 over 4. Right? We discuss these curves. So when the index is between 0 and 1, always the shape is this. When the index is between 0 and 1, always the shape is this. That's a standard curve. We discussed. Right? So simple as that. Take it down. Check your corrections. Check your corrections. Right? Is it all good up to here? Right. We are moving on. Moving on. See the last one. Sorry, not the last one. The fourth one. Fourth one. Right. T with T with 1 over root L. T with 1 over root L. Right. So you got the same or similar experience before in the previous question as well. Right. Now the equation is T equals 2 5 root L over G. So we can write it as, reshape it as 2 5 root G times root L. Right. Now if I need to include 1 over L here, right, we can write 1 over L as 1 over 1 over L. No? So if I use it here, see, without harming the equation, I can write this as 1 over root L. I can write this as 1 over root L. Now, if you simplify this, again, the same thing comes. No harm to the equation. I have reshaped the equation. Right? That is called reshaping. Reshaping an equation. Reshaping, or sometimes it's called rearranging an equation. Right? Now, identify the variables. T is y. 1 over root L is x. Huh? See, from the graph, 1 over root L is x. So, that is 1 over x. So, whatever it is as the product here is m. Y equals m 1 over x. That is inverse. That is an inverse curve. That is an inverse curve. Right? Next one. Fifth one. 5. 1 over t with root L. Fifth one. 1 over t with root L. 1 over t with root L. Right. 1 over t with root L. Okay. Look at the board. Again, the equation is same now. Equals 2 5 root L over G. Right? Now, 1 over t is given. Since 1 over t is given, I need to create 1 over t. And on the other side, root L is given. On the other side, root L is given. Root L is already there. So therefore, I'm going to keep root L without harming root L and going to create 1 over t on the left hand side. Right? So without putting both sides as 1 over terms, because I need just root L, not 1 over root L. So therefore, I'm not going to harm the right hand side now, and I'm going to change the left hand side of the equation like this. So I can write the same with this same thing, with this same idea, same concept, 1 over t. We can write this as 1 over t as 2 5 root G root L. 2 5 root G root L. Now 1 over t is going to be my y, no? 1 over t is going to be my y, right? 1 over t is y here, and root L is x here. So therefore, I'm going to cross multiply this and subject 1 over t. See, cross multiply the equation. Then 1 over t will be subjected. If we cross multiply, 1 over t will be subjected. And here, you will get root g over 2 5. Root g over 2 5 and 1 over root L. Right? I'm going to change the sides. 1 over t equals here root g over 2 5, 1 over root L. Okay. Now, the required terms are included. I'm going to identify the variables now. 1 over t is y. 1 over t is y. And root L is x. So therefore, this is not x, this is 1 over x. Root L is x. Right? Only root L is x. Huh? Only root L is x. And this is the gradient. So what's the shape? Y equals m 1 over x. 1 over x is an inverse curve. So this is an inverse curve. That is an inverse curve. Right? Next one. Next one. 1 over t with 1 over t with 1 over root L. Okay. I'll erase this. Okay. Sixth one. 1 over t with 1 over root L. Right? Am I clear? 1 over t with 1 over root L. Yes, that one. Now, 1 over root L is as x here. 1 over t is as y here. Right? Now again, go to the relationship we have. Go to the relationship you have. The relationship is t equals 2 phi root L over g. Right? Now, it can be written as t equals 2 phi over root g times root L. 2 phi over root g times root L. Now, if I observe these two, look at the board. If I observe these two, the left side is also 1 over term considered. And in the right hand side also, I have only root L, but 1 over root L is given. So therefore, I'm going to put both sides 1 over. For an equation, we can do anything for both sides. Right? For an equation, we can do anything for both sides. If we are adding something, we can add same thing for both sides. If you are deducting, you can deduct, you can subtract the same from both sides. If you are dividing, we can divide the equation, the both sides of the equation. So likewise, here I'm going to put 1 over. Now, as an example, like this, if I have, see, the example is this. If I have y equals x, if I have y equals x, I can write 1 over y equals 1 over x. If y equals x, 1 over y equals 1 over x. By putting both sides 1 over, right? Same thing. I can write this as 1 over t equals. If this is 1 over 2 phi over root g will be g over 2 phi. Root g over 2 phi. And this will be 1 over root L. Now, if I simplify this line again, the same one comes. Now, the two terms I needed to create are created. Two terms I needed to create are created. Identify variables. 1 over t is y. 1 over t is y. And 1 over L is x. 1 over L is x. And whatever it is as the product with x is gradient. So y equals mx. This is again going to be y equals mx. That is again going to be y equals mx. Right? Write it down. See how easy plotting graphs is, right? Can you see how easy it's to plot graphs? You just need to know that concept. You just need to know that concept. Get that idea. That's it. If anyone misses this session today, any one of your friends or someone, since this is a YouTube live, this will be anyway on YouTube forever. So therefore, feel free to share these videos with anyone that who might take an advantage from them, an advantage from these videos, right? Feel free to share with anyone because the purpose, the idea of having these kind of free sessions is to share this knowledge with everyone, right? To share this knowledge with everyone and to help you to get these marks that you are losing from graphs, right? Now, if you know how to plot graphs, definitely you will get these marks, right? එතකොට මේ ලකුණු ටික ගත්තට පස්සේ ඔයාලම තේරෙයි ඒක කොච්චර benefit එකක්ද කියලා. It's 15 marks, right? 15 marks out of 100, right? So therefore, feel free to share with anyone. පොඩි concept එකක් තියෙන්නේ. මේ concept එක ඔළුවට දාගත්තා නම් ඔයාට මොන ඉක්වේෂන් එක දුන්නත් ඔයාට කරන්න තියෙන්නේ ඔයා ඉක්වේෂන් එක මොඩල් කරගත්තා. ඉක්වේෂන් එක මොඩල් කරලා මෙන්න මේ ඕන විදියට y සහ x මෙන්න මේ දෙක හදාගන්න. ඒක ඇතුලේ ක්‍රියේට් කරගන්න. මේ මම කරගත්තා වගේනේ. දීලා තියෙන ඉක්වේෂන් එකේ yx ක්‍රියේට් කරගන්න. ක්‍රියේට් කරගත්තට පස්සේ ඔයාට අයිඩෙන්ටිෆයි කරගන්න පුළුවන් yx variables. අයිඩෙන්ටිෆයි කරගත්තු ගමන් ඔයාට ස්ටෑන්ඩඩ් ෂේප් එකක් ආවා නම් ඒ ස්ටෑන්ඩඩ් කර්ව් එක අඳින්නයි තියෙන්නේ. That's whole thing about it. That's all thing about it. Next one. Next one. Question 4. Question 4. Question 4. An object is released from rest under gravity. Plot variations of its velocity with fallen height h. Okay. Now a scenario is given. That's the scenario. An object is released from rest under gravity. Something like this. The object here is released from rest under gravity. So it undergoes a motion like this. Right? It undergoes a motion like this. And they are asking about fallen height. No, fallen height is from here to here. So this is the fallen height h. This is the fallen height. Okay, few variations are given. V squared with h. First one, see, V squared with h. Okay, look at here. Now, since the equation is not given, listen. Since the equation is not given, we have to create the equation. You have to develop the equation. Equation is not given. Now in previous two questions, equations were given, but now equation is not given. Like the first question. In the first question also, equation was not given. We had to apply an equation and get the correct relationship among these terms. Right? Now also, since I need a relationship between final velocity and fallen height, I'm going to use an equation like v squared equals u squared plus 2as, considering this motion. See, considering this motion, I can apply v squared equals u squared plus 2as. Now v squared is v squared. U is 0. So u squared is 0 plus 2. A is g. Fallen height is h. So the equation is v squared equals 2gh. See, the equation is v squared equals 2gh. Okay, now we can move on to the first graph. Take this equation directly. V squared equals 2gh. See, easily I can identify the variables now. V squared is as y, x is as x, h is as x. So h is x and 2g is going to be the radian. V squared is y. V squared is y. Y equals mx. So the shape is y equals mx. Right? Second one. V squared with root h. V squared with root h. Second one. See how easy this is once you got this. V squared with root h. Root h is x now and v squared is y. Right? Now again the same equation. V squared equals 2gh. Now I need root h. So we can create root h like this. 2g. This can be written as root h squared. No problem. Same. I change the shape without harming the equation. V squared equals 2g root h squared. Right? Now if you simplify this line, the same first line comes, original line comes. Now my requirement is satisfied. I have root h here. Now root h is included in the equation. Identify variables. V squared is y. Root h is x. Therefore, this is x squared, and whatever it is as a product with the x term, independent variable, whatever it is as the product with independent variable is gradient. Y equals mx squared. So the shape is this. Y equals mx squared. Third one. V with root h. Third one. V with root h. V with root h. V with root h. Now root h is x here. V is y here. Now again, the equation is the same. V squared equals 2gh. V squared equals 2gh. Now since I need V, I'm going to take the square root. So V is root 2gh. Right? V is root 2gh. I can write the same as, because I need root h as x, I can write the same as root 2g times root h. No problem. No problem, no harm. Root 2g times root x. Because you know from maths, root xy can be written as root x times root y. See? So from maths we all know that root xi can be written as root x times root y. Then root 2gs can be written as root 2g times root x. Now my requirement is satisfied again. Identify variables. V is y. V is y. And root h is x. This whole term root h is x. And this is gradient again. Y equals mx. Y equals mx. Y equals mx. Right? Next one. 4. 1 over v squared with 1 over h. 1 over v squared with 1 over h. Okay, I'll be erasing the first one here. Next one. 1 over v squared with 1 over h. 1 over v squared with 1 over h. Right? Now, 1 over h is my x variable. 1 over v squared is my y variable. Right? So, this is the equation we have. V squared equals 2gh. V squared equals 2gh. Now, once I observe this, I can see this is 1 over v squared. And this side also 1 over h. This side is also 1 over h. So therefore, if I put both sides 1 over, if I put both sides of the equation 1 over terms as 1 over terms, right? I can create both terms as at once, no? Right? If I put the equation as 1 over terms at once, I can create both terms, both required terms at once, right? So we got the same experience in the previous question as well. Same thing was there in the previous one. So this can be written as 1 over v squared equals 1 over 2gh. Now, if I isolate 1 over h, this can be written as 1 over v squared equals 1 over 2g times 1 over h. Right? So, since there is a multiplication, right, it is like this. If you have 1 over x times 1 over y, see, let me write it here. If you have 1 over x times 1 over y, it can be written as 1 over xy. Like this. If you have 1 over x times 1 over y, it can be written as 1 over xy. So opposite also works. So if I have 1 over root 2gh, we can write it as 1 over 2g times 1 over h. My requirement is satisfied. 1 over h is created, 1 over v squared is created. 1 over h, this is my x. And 1 over v squared, this is my y. And whatever it is as the product is m, y equals mx again. Y equals mx again. y equals mx again. Okay. Ask any questions if you have. You can ask any questions if you have. Now we have discussed around up to here how many graphs? 4, 6, 10, 14, 16 graphs up to here. Now we have already discussed 16 graphs. So if you have any questions, please ask. Right? So I'm always looking at the YouTube chat. Right? So you can ask questions if you have anything. I'm always looking at the chat here. So you can ask questions if you have anything. Right? Now with this question, now we have discussed 16 graphs up to here. Okay, moving on. Go to next one, question 5. Go to question 5. Go to question 5. So you can try out. You can try out and you can check your answers with mine. You can try out and check your answers with mine. Try out and check your answers. Question 5. An object is released from rest under gravity. Same scenario. See, an object is released from rest. U equals 0 under gravity. So it undergoes a vertical linear motion under gravity. Right? Plot variation of fallen height with time. Now with time. Variation of fallen height with time. Fallen height is from here to here. Let's say h. Right? And let's say this is t equals 0 of this motion. And at this point, this is t equals t of this motion. Time t has passed. Right? Now I need the variation. I need to plot variations with h and t now. Right? H and t. Then we have to create an equation. You have to develop an equation. You have to build up an equation having variables h and t. Right? So apply a linear motion equation again. If the equation is not given, we are the one to create the equation. We are the one to develop the equation. So once the equation is developed, again we can do the same. See, to do the same, so I'm using s equals ut plus half at squared downwards. S is h, u is 0, so ut is 0 plus half acceleration is g t squared. So the equation is h equals half gt squared. H equals half gt squared. Having that in hand, now let's go to the graphs. First one, h with t squared. First one, h with t squared. H with t squared. Now in my graph, x squared is acting as t squared is acting as x and h is acting as y. My proved equation is this: h equals half gt squared. Right? Now all terms are already here. All the required terms are already here. Right? So just identify the variables. H is y and t squared is x. T squared is x and half g is gradient. Y equals mx. Y equals mx. Second one, h with t. H with t. Now in this one, tx as x, h as y. Again, get the same equation. H equals half g t squared. All the required terms are already created. So this is just a step away from identifying the labels, identifying the variables. H is y. T is x. So therefore, t is x. Only t is x. Therefore, t squared is x squared. T squared is x squared and half g gradient. y equals mx squared. This is the curve. Y equals mx squared. Next one. What is the next one? H with t to the power 4. H with t to the power 4. H with t to the power 4. Now t to the power 4 is not included in the equation yet. T to the power 4 is not included, not available in the equation yet. Then we have to develop it, right? So reshape the equation without harming the equation. Reshape the equation without harming the equation. My equation is h equals half g t squared, right? So I can include t to the power 4 to the same equation as half g root t to the power 4. Half g root t to the power 4. Right? No harm to the equation. No harm to the equation because x can be written as root of x squared. No? So similarly, x squared can be written as root of x to the power 4. So I use this. Right? So t squared can be written as root t to the power 4. Root is power of half. Then 4 into half cancels. T squared comes again. Change the shape of the equation without harming the equation. Very simple. H is y and t to the power 4 is x. T to the power 4 is x. So therefore this is root x and this is gradient. Right? So y equals m root x. M root x is a standard shape. This is the shape. M root x is a standard shape. M root x is standard shape. Next one. 1 over h with 1 over t. I'll erase the first one. Fourth one and the last one. 1 over h with 1 over t. 1 over h with 1 over t. Right? Look at here. One over h with 1 over t. My equation is again h equals half gt squared. H equals half gt squared. Okay. Now y-axis is 1 over h and x-axis is 1 over t. So apparently both sides are considered as 1 over terms. No? Apparently both sides are considered as 1 over terms. So therefore, I'm going to put both sides as 1 over sides. Right? This can be written as 1 over h equals 1 over half is 2. Right? Now, if you don't get it, I'll write everything. So this is 1 over half. 1 over half. And this term will be 1 over g. And this will be 1 over t squared. Same, no? I have put both sides 1 over. Then if I simplify this, 1 over h equals 1 over half is 2. And this is 1 over g. Then 2 times 1 over g. And here 1 over t squared. 1 over t squared. What I need is 1 over t. Now again I am going to reshape this equation as 1 over t is created. See what we can do? This can be written as 1 over h equals 2 times 1 over g is 2 over g, no? 2 over g. Right? And this can be written as 1 over t, the whole thing squared. There's no harm to the equation. No harm to the equation. Why? There's no harm to the equation because now we can write 1 over x squared as 1 over x whole thing squared, no? Because the square of 1 is also 1. Square of 1 is also 1. Then 1 over x squared can be written as 1 over x whole thing squared. Then square of 1 is 1. The square of x squared is x squared. The same term comes. So therefore, 1 over t squared can be written as 1 over t whole thing squared. Now my requirement is satisfied. Requirement is satisfied. I have finished modeling the equation. Now I have taken the equation to the standard shape. Now identify variables. Identify variables. 1 over h. 1 over h is y now. 1 over h is y. 1 over t is x. 1 over t is x. So therefore this is x squared. This is x squared. And whatever it is as the product with the x term is gradient. So the shape is y equals mx squared. Y equals mx squared. A standard shape. Y equals mx squared. A standard shape. Okay. Okay. Take it down. Take it down quickly. Now with this, we have discussed 20 graphs today. With this, we have discussed 20 graphs today. 20 graphs. Right? Now you can clearly see and you can clearly understand how a graph is product. That's not a big deal. Very small concept. I mean, that is a simple concept. That's a simple concept. If you get it properly, definitely you would score the graphs in your main exam, right? Okay. Now listen. So with that, we have finished discussing the graph plotting session, and now what we discussed today was I started from the scratch, and we discussed everything, every theory part that you need to know about graph plotting, and then as exercises we discussed 20 graph questions, right? So those are the graph types you are getting, right? So therefore, please go through these things again and again, because I told you the gravity of graph questions are very much high. Around 15% of marks will be allocated for graphs. So therefore, always try these questions again and again and fine tune your skills and improve your skills, right? And if there's anyone who missed the session today, since it is a very important session, a significant lesson, I took it exclusively from my theory class and conducted as an exclusive session for graphing. So if there's any friends who has missed this, right? Any friends who have missed this, you can share the link, share the video with them, and let them take the advantage, right? Because once you score at the exam, right? Once you score the graph questions at the exam, then you will see the impact of these ones, and you will score around 15 marks in the exam, right? So that's the thing. That's the thing. Right. All right. Then I hope you understood everything today. And quickly, I'll give you 2 minutes to ask questions if you have anything. Uh, please ask me questions if you have anything. And if all clear, say it's clear. And if you have any doubts, quickly ask your doubts, because I'm going to wind up the session. Now it's 9:30. Yeah, I'm going to wind up the session. Uh, I need a quick response from you guys. A quick response. What about the session? What about the session? Have you understood everything? If you have understood everything, say it's clear in the chat box. And if you have any doubts, anything to clarify from my end, you can ask anything now. You can ask anything now, right? Not just from the session. If you have any other thing related physics, related to the subject, related to classes, you can always ask. Quickly. Please respond. Please respond. Please respond. Are you all clear? All clear? All good? Everything okay? All understood. Very good. Yes, clear. Good, good. Very good. Very good. So that's what I wanted. Because this is not a big deal. This is a simple concept. Once you understood that concept, you can draw hundreds of thousands of graphs with the same concept. Huh? Concept remains same. Everything clear. Good. Concept remains same. Right? Now, even if I give you hundreds of graphs, thousands of graphs, concept is same. Once you understood this concept, you can plot any number of graphs without any hassle. Right? Okay then. So that's good to see the responses from you guys. Right? Very good. Yeah, that's very good to see the responses from your side. Okay, then I can see that you have got something from the session, and you have got the most out of the session with the 20 exercises I have discussed. Right. So therefore, now at this point, I'm going to wind up the session. That's it for graphing. Now you know everything regarding graphs, right? Yes. Yes. Okay. Now you know everything regarding graphs. Now plot more graphs and fine tune your skill that you have got today. I mean, fine tune the skill that you have uh, acquired today. Now you have acquired this skill today, no? Right? So therefore, consistently work and fine tune the skill. Right? For 25 students, you just got 19 weeks ahead of the exam now. So work hard, and for 26 also, your exams are coming up next year. So time flies, time flies. So keep these skills fine tuned, because this is a skill. It's needed throughout all 11 units. Right. Okay then. So then I'll wind up the session here. Study hard, work hard, and you can achieve your goals. Right. Okay, and stay connected to my channels and groups to get to know about the future updates about the free sessions and my classes, right? And especially I'll be putting everything in my Telegram channel. So stay connected with the Telegram channel, right? So I'm winding up the class here. Goodbye, good night, and stay safe, right? Goodbye.